So here we go. We have our FBD, free body diagram drawn, and that has been taken from the space diagram which is up here. Remembering that the difference between the space diagram and the free body, the space diagram shows the situation as it actually is in real life. Free body, we get rid of all the junk around it, so it's broken down into a simpler way that we can understand that will help us do the equations. Now, before we go any further, again, we need to look at this as an engineering problem. Here, we've got one roller and one pin. But if I was to actually draw the top view of this bridge, I would find that there would be possibly more than one pin here or more than one roller. You'd find that there'd be at least two sitting there, so it can support the weight. If it was only on one side, the bridge would fall over. And the same would be here for the pins. In this case here, we've got trusses running all the way down this side of the bridge, as well as this side of the bridge here. What I'm getting at here is that like these weights are for the total of the bridge, the total. Whereas what we actually are doing at the moment, we can calculate the totals, which is fine. However, when it comes to later on, we're going to have to divide it by 2 in this circumstance because we're only working on half of the bridge. Okay. Now in the HSC, you're not going to get a question like this, but I'm trying to tie this back to real life. These calculations that we're doing will be based on half of the bridge, especially when we start doing the method of joints and the method of sectioning. So here you've got a decision to make. You can either keep the bridge as a whole, or we can start splitting the weight up now so it's easier to understand later on. So what I'm going to suggest that we do is I'm going to divide the weight here, but I'm actually going to make sure that it's understood that this is the reason why. Okay, so I want to make sure that the reader of my report understands it, so I've got to make sure that I've got some form of quote like this in here. Right, so now that I know that what I'm doing, let's just keep it simple at the moment. With this one here, the truck, which equals 480, will now come down to being 240 kilonewtons for the purpose of half of the bridge. Half of the bridge. Okay, so here we're going to have 240 kilonewtons. Yeah. Not quite complete yet, but I'm just going to leave it there and I can tick that off because I know that I've calculated it. I also know here, and this is what I've got to look at, I've got an overall weight of 7,850 kilograms, or kilograms per cubic metre. I know that I have 44 metres of bridge, and then I know that I've also got to turn it into newtons by timing it by 10 to get gravity. Okay, so clear, 7850 by 44 by 10 equals. So we've got 3,454 kilonewtons. Again, I'm wanting to divide it by 2 here because I'm only looking at half. I'll divide that by 2. Clear. 3,454 divided by 2 equals 1727. Again, I'm still trying to solve this problem. Like I know that that is the overall weight, but I have different sections on this bridge. I've got 11 sections of 4 metres, so I'm just going to divide this by 11, which equals 157 kilonewtons per section. Okay, per section. So you can see here, like the math isn't difficult. I'm just going to rub this out so I can get some space. All right. The math isn't difficult. It's actually seeing reasons why and understanding why we're doing the math. Okay, so I know that this here, if I have come back to my bridge design at the moment, here is my first section. All right. So I know that that is 4 metres. I've then got a second section here, so I've got 2 sections. So this first one, if I come back to my FBD, I know that that is 4 metres and that is 4 metres. And you can see as well here, the truck also takes over another 4 metres here and another 4 metres there. Now, if I do the calculations, I know the bridge is 44 metres in length. So 44 less 16 equals 28. So, and I've got 2 sections to make up the total of 28. So that's going to be 14 and that's going to be 14 as well. I need these distances because when I start doing my moment calculations, it's basically force by distance. So I need to know what this is. So it's a total. Right, coming back to my bridge design. Sorry, my actual forces in play that I already know about. I have 2 sections and each section is 157 kilonewtons. So that there is now 314 kilonewtons. I said the truck as well also has 314 kilonewtons, which is that section of the roadway. And again, we're taking it from the centre. When it's like, if we're looking at if this was a box, we take the weight from the centre of the box. If it's a universally distributed load, like we've drawn here, it comes back to the centre of the load. So again here, I've got 314 plus 240, which equals a total of, let me just erase this out so I know that I've got this right. Coming back to my pen. Right, so I know this now here is 554 kilonewtons. Again, I'm just keeping it nice and simple. So here I've got 28 metres, which is 1, 2, 3, 4, 5, 6, 7 sections of road. So clear 157 by 7 sections equals 1099 kilonewtons. Okay, so now you can see I've got my free body diagram ready to go. I've got all the information that I actually know now at the moment put into it. So my next step is I can start going in and doing the calculations.